Munib.
Bismillahirrahmanirrahim. Quote of the day: Smile, even if your heart is dripping blood. By Hazrat Ali alayhi salam. Today, I'm Dr. Munib Altaf, and today I'm going to present estimation risk and association under supervision of Professor Dr. Sahir Afzal. Learning outcome. By the end of the session, participants will be able to differentiate among the odd and risk along with its variants, basics of calculation of odd, relative risk and result interpretation, and indication of applying risk parameters, and some recent updates about the risk. And so what is the probability, risk, and odd? Probability, it is a proportion of times an event can occur if multiple times repeated observation are done. And the risk, it is a probability of an event among those who are exposed to event divided by the numbers who could experience it, or we can say who are at risk. Odd ratio, it is the probability of an event divided by the probability of an event not happening. So now comes the risk. There are following types of risk: absolute risk, relative risk, attributable risk, and population attributable risk. Absolute risk. The incidence of a disease in a population is termed as absolute risk. Absolute risk tells us about the magnitude of risk. In a group which is having certain exposure, it will not take consideration the risk of a disease in non-exposed group of population. And the association of exposure and increased risk of a disease is not explained by the absolute risk. Absolute risk does not stipulate an explicit comparison. For example, rubella infection in the first trimester of pregnancy. So, what will be the risk of a child being malformed? And the abortion will be decided on the basis of this information. So, abortion cannot be decided on the incidence of the malformation due to the rubella infection in first pregnancy. So here's the formula of absolute risk in the new cases and the control cases. It is actually the events occur in the A, and in the control it's C. The interest where does not occur, it's B and D. So formula will be A divided by B plus C for the new cases, and for the control it will be C divided by C plus D. Now the relative risk. Relative risk is used to determine that a certain disease is associated with certain exposure. In the case control and cohort studies, we can assess whether there is an excess risk of a disease in a person who has been exposed. An excessive uh, risk of a disease can be assessed by comparing different risks among different groups. Estimation of relative risk is essential in determining that which group will be at high risk after the exposure. It is more related to the clinical researches to show the relation of a disease and factors. Case control and cohort studies are designed to determine whether there is an association between exposure to a factor and development of disease. And if there is association, then how strong it is. In the cohort study, relative risk will be the ratio of risk of a disease in exposed individual to the risk of disease in non-exposed individuals. Here's the formula. Risk is equal to the risk, which is the incidence of a disease in exposed divided by incidence of a disease in non-exposed. Here you can see the basic structure of cohort study. From the starting point, we are to move in the future, and this is the population. We will take the sample from the population, and then one of the section will be exposed and the other will not be exposed and expressed to the factors. And then we will see the results that how many of the people develop a disease, how many remain disease free in the both sectors and the both groups, and comparing the incidence of a disease in each group will be done in the cohort study, and the relative risk will be calculated for exposure. Relative risk calculation, this is the example, a 5 years cohort study in which the evidence of disease is exposed was compared with that of unexposed. So is a disease or not disease, and on the other side there's exposed, which can be smoking, or non-exposed, which is the non-smoking. So after smoking, the total diseased cases was 70, and in the non-smokers, disease cases was 3. And when there was no disease, 6,930, and in the non-exposed group, there was 2,997. So if we will calculate the incidence on the both exposed and non-exposed group, there will be 70 divided by 7,000, and we will divide it again 3 divided by 3,000. So the answer will be 10. So interpretation with the relative risk of 10 indicates positive association. It means that smokers are 10 times at greater risk of developing lung cancer than the non-smokers. Here you can see the explanation of the relative risk. Relative risk of 1.0 is the baseline. Okay, and if a relative risk is greater than 1, means the risk is increased, and a relative risk of 1 means there is no association between the factor and risk factor and the disease, and the relative risk less than 1, that mean that the risk between the factor and the disease is decreased. And if the relative risk is more than 1, we can say 2 or 3, it will be 3 or 2 times more risk of having a disease due to that factor. Now come to the attributable risk. It is the difference between the incidence of a disease in an exposed and non-exposed group. It is expressed in percentage. Attributable risk indicates to what extent the disease under study can be attributed to the exposure. Here is a formula. The incidence of a disease rate among exposure minus incidence of a disease among non-exposure divided by incidence rate among the exposed multiplied by 100. So this is the example, the contingency table applied to the hypothetical cigarette smoking and lung cancer example. Again, it's if someone, and there are two groups, one developed the disease, lung cancer, other did not develop the lung cancer, and the exposure factor is the cigarette smoking, yes or no. So we will have this, we were already seen this table. So this is the example. Now we will explain one by one about the incidence and relative risk and attributable risk. So the incidence of exposed was 70 divided by 7,000 is equal to 10 per thousand, and incidence in non-exposed is 3 divided by 3,000, so it's 1 per thousand. It shows that there is more chances of having lung cancer in smoker than the non-smoker. Now, again, the same example, and we will calculate the relative risk. The relative risk is the incidence in the exposed divided by incidence in non-exposed. So incidence in exposed was 10 per thousand, and the incidence in non-exposed was 1 per thousand. So relative risk is equal to 10. So it shows that smoker have 10 times more chances of having lung cancer than non-smoker. And this is the attributable risk formula. The incidence of disease rate among exposed minus incidence of disease among non-exposed divided by incidence rate in the exposed. So attributable multiplied by 100. So here the incidence in disease was 10, and incidence in non of disease in exposed was 10. Incidence in non-exposed was 1. So that is equal to 9 divided by 10 was the incidence among the exposed group. Uh, and we will multiply it with 100, so that will be equal to 90% of attributable risk. So it means that it shows that 90% of the lung cancer among smoker are due to smoking. This suggests that among of the disease that might be eliminated if the factor under the study can be controlled or eliminated. So it is important for the public health purpose. For example, the elimination of smoking or the other smoking habits will hope to decrease 90% cases of the lung cancer which occurs due to smoking. Now, it's population attributable risk. So, what proportion of a disease incidence in a population can be attributable to a specific exposure? It will be useful to determine the expected impact of prevention program on the community. So is the formula for the population attributable risk. Population attributable risk can also be expressed as the fraction or the percentage. So population attributable risk is equal to the incidence in total population minus incidence in non-exposed population divided by incidence in total multiplied by 100. So now we will take the example of chronic heart disease in smokers and non-smoker. Again, the smoking occurs and does not occur and develop the chronic heart disease and does not develop chronic heart disease. Total in the smoker cases are 3,000, the non-smoker are 5,000. So when we will calculate the incidence per thousand year, we will see that the incidence among smoker was 84 divided by 3,000 is 28 per thousand. And incidence in non-smoker is 87 divided by 5,000, it's 17.9 per thousand. So the attributable absolute risk will be the attributable risk will be the incidence in the exposed and non-exposed is the 28 minus 17.4 divided by 1,000. That will be equal to 10.6. In proportion, it will be said that attributable risk 28 minus 17.4 divided by 28, which is the incidence among the smokers multiplied by 100. That will be equal to 37.9. So 37.9 of the morbidity from chronic heart disease among smoker may be attributable to smoking and could presumably be prevented by eliminating smoking. Now, assuming that the incidence of smoking in total population is 44, then the non-smokers will be definitely 56%. Incidence in total population can be calculated. The incidence in smokers multiplied by a percentage of smokers in population plus incidence in non-smokers uh, multiplied by percentage of non-smokers in population, and then the attributable risk in the population will be 21.3. And again, this 21.3 is the incidence of chronic heart disease in the total population can be attributed to smoking. So if an effective prevention program is there to eliminate smoking, the best way could hope to achieve would be reduction of 21.3% in the incidence of chronic heart disease in total population. And the population may consist of both smokers and non-smokers. And now, what is the R ratio? Odd ratio is a measure of association between exposure and outcome, and it shows that odds that an outcome will occur in a given particular exposure than the odds of outcome in the absence of that particular exposure. In cohort study, we have values of incidence in exposed and non-exposed, so we can easily calculate the relative risk. Although order ratio can be used in cohort and cross-sectional study with some modification, while in case control study, the incidence in the exposed and non-exposed population is not known, so because we start with the diseased people and non-diseased people. So we cannot estimate the relative risk in case control study directly. So we will have to go for another measure of association, which is odd ratio. So odd ratio is commonly used to measure odds in the following studies: studies of any rare disease in which the prevalence is less than 10%, case control studies, and the meta-analysis. Here's the formula and the calculation of the odd ratio. The odd ratio is actually the cross multiplication of diseased and non-diseased cases in exposed and non-exposed factor. Odd ratio will be, if we will say that cases exposed uh, and diseased, so it will be A, and exposed plus not diseased, it will be B, and the cases which are cases not exposed, so it's C, and not exposed plus not diseased, this is the D. So we will go for odd ratio will be AC divided by B by D is equal to AD divided by B and C. So prevalence among the disease and prevalence among the non-disease. So we will see that if the odd ratio is equal to 1, the exposure does not affect the odds of outcome. And if odd ratio is more than 1, exposure associated with higher odds of outcome. And if odd ratio is less than 1, then exposure associated with the lower odds of outcome. Here's the example of smoking and lung cancer. Again, we can see that smokers who got the lung cancer are 80, and who do not get the lung cancer are 30, total are 110. And the non-smoker, the lung cancer occurs in 20, and the not developed lung cancer was 70, total was 90. So if we will calculate the odd ratio, it will be 9.33. Now another example, in this example, it's uh, hormonal replacement therapy in the woman. So total of 13 and 27 women aged of 50 to 81 years with the hip fracture who lived in large urban area in Sweden were investigated in unmatched case control study, and they were compared with the 3,262 control with the same age group range selected from the National Register. And the interest was centered on determining whether postmenopausal hormone replacement therapy substantially reduced the risk of hip fracture. And the result in the table will show the woman who currently using the HRT and who have formerly used. Here we can see the currently users and no never used group and currently used group with the hip fracture and without hip fracture. So the observed or ratio will be 0.39. So the postmenopausal woman in this age range in Sweden who was a current user of HRT had 39% of risk of hip fracture of a woman who had never used a formally. So, being current user of hormonal replacement therapy reduced the risk of hip fracture by 61%, as 39% is the odd ratio. Calculating the odd ratio in matched pair case control study according to the type of exposure. Case control studies can be classified into four groups: concordant pair and discordant pair. The concordant pair, pairs in which both cases and control are exposed, and concordant pair, the other section is a pair in which neither the case nor the controls are exposed. And discordant pair are the pair in which the case was exposed but control was not exposed, and pair in which the control was exposed and case was not exposed. So in this case, we will see this 2 by 2 table and showing that we will calculation entail the discordant pair only. Only B and C will be used in calculation. We will ignore the concordant pair because they do not contribute to our knowledge of how cases and control differ in regard to the past history of exposure. So they did not give enough knowledge to take them in the consideration of the study. That's why the odd ratio will then equal to B divided by C. Now it's time for recent updates. Regional relative risk, a physics-based metric for characterizing airborne infection disease transmission. So that was published in 2021. So in the abstract, it shows that physics and biology-based model can assist in predicting airborne transmission events, overall disease incidence, and disease control strategy efficacy. So in this article, the author says that we propose the regional relative risk, a new metric distinct from the traditional relative risk metric that compare the risk between the two regions. In theory, these region can range from individual rooms to the large geographic area, and this will provide context for initial stage of an airborne disease outbreak and large-scale disease spread, including unexpected low probability disease sparks that potentially affect the remote population, a key practical issue in controlling the airborne disease. The second is the ratio estimation in longitudinal study. It was published in January 2019. So in this study, longitudinal studies are very common in medical behavior, behavioral and interventional sciences. In this study, authors said that odd ratio do not well approximate the risk ratio when outcome is common. So alternative method have been introduced in cohort study with one follow-up visit. In this paper, they illustrate the two methods. One is copy method, other is modified log Poisson regression method for risk ratio estimation in longitudinal data setting. It's time for MCQs. MCQ number 1. A newly appointed district health officer received the complaints of new cases of disease in Sharipura. What will he calculate to get the magnitude of risk? A is relative risk, B is population risk, C is absolute risk, D is odd ratio, and E is mortality rate. The answer is C. To get the magnitude of risk of the new cases incidence, it will be the absolute risk. Question number 2. A doctor received many cases of conjunctivitis in last 2 weeks. So he came to know that there is a new factory open nearby. What risk will he try to calculate to prove that disease is due to the factory waste aerosol? So and options are absolute risk, attributable risk, relative risk, relative odds, and disease risk.
C.
Yes, it's C, relative risk. After doing research, doctor find out that the value of the relative risk has been he calculated is 1. What will be the relation of disease with the exposure? There is high risk of having disease after exposure. There is no relation between the exposing factor and disease. There is low risk of disease and factor relation. There is high risk of disease after decrease in causative factor, and there is lower risk of disease after increase in exposure.
B.
B.
Yes, B is the right answer. If the relative risk calculated is 1, then there is no relation between the exposing factor and disease. In this MCQs, as we can see, the smoking status and development of CLD in the exposed and non-exposed group. So this is the cohort study and development of CLD with the association with smoking is observed. So what will be the relative risk in this case? This is a little bit calculation. Firstly, the incidence of the exposed and non-exposed group will be calculated, and the final answer is the C, right, Dr. West?
C.
1.25 C. Question number 5. A public health official wants to run a preventive program of smoking in relation with the CKD, and he also wants to know the expected expected effect of this program on CKD? Which of the following variant of the risk will he use for it? Population attributable risk, odd ratio, absolute risk, and relative risk and modified log percent.
B.
Yes, A is the right answer. It's the population attributable risk, which is used to know the expected effect of any program. Question number 6, a pulmonologist in the interior scene want to conduct a study on tuberculosis and poor hygiene. He selected 240 cases and 240 control. What is the risk variant which is commonly used in this type of study? A is relative risk, B is attributable risk, C is absolute risk, D is regional relative risk, E is odd ratio.
E.
E is the right answer. Odd ratio is used. This is a question. A doctor did a case control study on the smoking and lung cancer, and the smokers who developed lung cancer at 30 and who did not develop lung cancer at 90, and non-smoker who developed lung cancer at 30 did not develop lung cancer at 70. So, what will be the value of odd ratio?
C.
Yes, C is the right answer. It's a cross multiplication. So 70 will be multiplied with 30 and 90 will be multiplied by 20. So it will be 20. Here you can see 2100 divided by 1800. So the answer is 1.16. Question number 8. A researcher did a case control study according to exposure. He only considered the discordant pair and calculate the odd ratio accordingly. Why concordant pairs are not used? Because they give more knowledge how case and control differ in exposure. They give less knowledge how case and control differ in exposure. Only case is exposed to exposure factor, and only control is exposed to exposure factor. Uh, the answer is B. Concordant pair are not used in the study because they give less knowledge about the control, and cases differ in the exposure due to the past history. And now, the question number 9, in the article, author gave the theory of new metric related to airborne disease, which is called the regional relative risk. According to author, which of the following will be predictable by the new metrics? Transmission and incidence, diagnosis, treatment, D is latent period, E is recovery period.
A.
E.
A is actually the right answer. Transmission and incidence of the airborne disease will can be predictable according to author. In the article, author explained the odd ratio is not a good parameter to measure the risk ratio in longitudinal study. So, what are the other alternative method he gave? A is copy method, B is logistic method, C is by log binomial method, and D is modified log binomial method.
B. Logistic method.
So the article I explained was it was the copy method which he used, and supported that copy method should be used instead of odd ratio. This is the key, and thank you.
Thank you very much. Very nice presentation, especially the calculations were the highlights, and how the different calculations were correctly interpreted, and they are being related to the scenarios and the real time important findings that we have seen over the years, especially the evidence about hormonal replacement therapy in women. And the 61% is a key number that has shown the risk. Similarly, how the odds ratio, absolute risk, relative risk, they have been calculated. It is wonderful. Thank you very much. See you today, inshallah, in the department at 9 a.m. Thank you. Allah Hafiz.
Thank you, madam. Allah Hafiz.